Hey, I've got a friend, and it has nothing to do with math, but I think you'll really want to meet my friend. Look at that. Her name is Fluffy. Fluffy, can you look at the camera? Oh, it's really tough. Oh, there you go. And I just thought if you're interested in me and want to know who I know, this is one of my friends. Fluffy, why don't you stay right down there? And see, I might have to readjust my microphone. Okay, today we're going to be studying scientific notation. Now, scientific notation is taking very large numbers and reducing them to a unit value. We take that unit value and we multiply it times 10 with an exponent so that it ends up being the same number. We can also take really small numbers and we elevate them to the units position, and then we multiply it times 10 with a negative exponent so that, again, it's the same number. Now, these two numbers you're looking at are not really large numbers or really small numbers, but we're going to work with these numbers so that you can see what I'm talking about. Now, the reason why we do this, well, there's lots of reasons why we do this, but in chemistry and in physics, and I'm sure other mathematical things like calculus and I don't know what, it's very necessary to use scientific notation. Now, if in chemistry, if I'm talking about enough molecules so that I have a gram, we're talking about just numbers that are so big we don't have a name for it. Or if they do have a name for it, I sure don't know what it is. And if I say, well, how small is that atom of hydrogen? Well, it is so small that we need 0.000000. And if you're looking at that number, you just can't make any sense of it. At least with large numbers, we have commas on them. With smaller numbers, we don't. And so we use scientific notation. So if I say, well, it's 1.26 times 10 to the negative 23rd. Well, that's helpful if you're a chemist anyways. And the same is true with physics and a lot of other sciences. But let me show you how this works. We're going to take 14,200 and we're going to reduce it to 1.42. Now remember I said we're going to reduce it to the units value? Well, that number has to be between 1 and 9. Okay, so the first number has to be between 1 and 9. It can be anything less than 10, which would be 9.99999, something like that. But that first number has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. It can't be 10 and it can't be 0. And so you can see in this problem, it's going to be 1.42. So we're going to start with 14,200 times 10 to the 0. Now what's 10 to the 0? Well, if you remember from our last lesson, any number to the 0 power is what? That's right, it's 1. So we're just multiplying 14,200 times 1. Now as we reduce 14,200, we're going to have to elevate that exponent. So let's move that decimal. Remember, if there isn't a decimal in a number, it's assumed that it comes after the number. So we know that 14,200 is 14,200 decimal point. Okay, so let's take that decimal point and we're going to move it to the left until it hits the unit spot. So how many spots did we move it? We moved it 1, 2, 3, 4. So what do you think we're going to do with the exponent on that 10? That's right, as we move the decimal point 4 places to the left, we're going to elevate the value of the exponent by the same amount. 4 to the left, and so it's going to be 10 to the 4. And if you put that in a calculator, you're going to see that both of those numbers are the same. And you know something? we really shouldn't have commas in there anymore. And those zeros are superfluous. Now those zeros might not be superfluous if the question states that I want the problem written in scientific notation with 4 places behind the decimal point. And then we would have need those 2 zeros, but that is not the case here. So let's work on the next one. We're going to move our decimal point to the right until we get to the unit spot, or that is until we get in front of the unit spot. So I moved it 3 places. So it's going to be times 10 to the, no, it's not going to be 10 to the third. It's going to be 10 to the negative third because we moved the decimal point to the right, not to the left. To the left, the exponent gets bigger. To the right, the exponent gets smaller. And we got a bunch of zeros that we don't need. And that is what that will look like when you're done. So, if we move our decimal point to the left, the exponent gets bigger. If we move the decimal point to the right, the exponent gets smaller. Now, if you have trouble remembering that, boy, I sure do too. And this is the way I look at it. As this number got smaller, this number got bigger. As this number got bigger, remember it was a really small number, 0.0042? I think that's what it was. And so we made it a lot bigger. So if we make this bigger, we're going to make that smaller. Let me show you how that works, just so you'll remember. We did this in an earlier lesson. In this example, I have a value of 8. I can multiply 1 times 8 to get there. I can multiply 2 times 4 to get there. I can multiply 4 times 2, or I can multiply 8 times 1. Now they're all the same value. Just like our scientific notation, the 2 numbers that we started with and ended with, both of those numbers have the same value. And it always has to be that way. And so what did we do? The same thing that we're doing here. Do you see? As this number gets bigger, this number has to get smaller. And that's just the way multiplication works. And so it's easier to think of it that way, is as our number is getting smaller, our exponent has to get bigger. Or if we're taking a really small number and we're making it bigger, then our exponent has to get smaller. Because it's really hard to memorize that rule left to right and right to left, especially if you're doing it backwards like we're going to in this next problem. Okay, here we have a number in scientific notation and they want us to convert this to the normal format. So we have a number with times 10 to the 5th, which means we're going to have to move this decimal point which way? Well, if we're making that smaller, remember we're going to reduce that to 0. That is, we're going to get rid of this. If we're making that smaller, we have to make this bigger. By how many decimal points? 5. Okay, we move that decimal point over 5 spots. I hope you can see it right there. And we wrote the exponent from 5 down to 0. This number got smaller. This number got bigger. Smaller, bigger. Bigger, smaller. Okay? You're not going to do both. You're not going to make both bigger, and you're not going to make both smaller. So if you make that smaller, you're making this bigger. Now, let's get rid of that 10 to the 0. That's worthless. And we really don't need that decimal point because there's nothing behind the decimal point. You don't really need a decimal point if you don't have a number beyond the decimal point. And of course, you don't write big numbers like that unless you put a comma after the first 3 places. There you go, that's the answer. And let's see how this works with a small number. Okay, our 10 has an exponent of -3, and we're going to go from -3 to 0, which is a bigger number, right? Going from -3 to 0 is a bigger number. This is getting bigger. That's right. This is going to get smaller. By how many decimal places? 3. So we move the decimal point 3 places to the left, and that makes our number really small. And we took our exponent of -3 and we elevated it to -0. Come on, you don't put a negative in front of the 0. And while you're at it, get rid of the 0, the 10, and the x, because we don't need all that. And that is our answer. The book and I think most mathematicians like a 0 in front of that decimal place, but I don't. It seems to add to confusion to me, because if I'm asking how many zeros are there until we get to the number, I'm counting my zeros and I'm going, oh, wait, don't count that first 0. So I don't put zeros in front of a decimal place. You can if you want. Mr. Wallace does. Like I said, most mathematicians do. I don't. So let's try a problem where we're multiplying numbers with scientific notation times other numbers with scientific notation. And let's see how that works. And this looks really complicated. It's not. It looks complicated because you haven't done it before and you don't know the rules for executing this. But let's just start by multiplying the units place first. And that's 7.77. That's not too bad. And we're going to multiply that times 10 with an exponent of what? Now remember our rules for multiplying exponents. First off, we have to have a number value or a variable that is the same. Our number value is 10 in both, so no problem there. And what do we do with our exponents? That's right, we add them. So let's do that. Yeah, it's -7 plus 5. What's -7 plus 5? It's -2, and that's our answer. 7.77 times 10 to the -2. Now let's try this with division. Okay, we're going to attack this problem the same way. And we're going to deal with the units first, like we did in the last problem. So let's divide out the units, of course. Instead of multiplying them, we're going to divide that out and multiply that times 10. And of course, that needs a proper exponent. Now, what do we do when we divide with exponents? Remember, when we multiply, we add the exponents, and with division, that's right, we subtract the exponents. So let's do that. So if you look above, it's 4 minus 3. Now don't do 4 minus 3 and leave out one of the negatives. It's 4 minus 3. Now what is minus 3? That's right, you've done that several times, and we need to turn minus into plus. So 4 plus 3 is 10 to the 7, and that's our answer. 1.6 times 10 to the 7. Now let's deal with scientific notation when we're dealing with a power of a power. Okay, we have a number with scientific notation within a parentheses, and that parentheses has an exponent, and what is that exponent relative to? Well, it's relative the thing that it's next to. What's it next to? Parentheses. I know we've gone over that quite a bit, but I want to make sure that we don't lose you just because we're doing something different like scientific notation. So, what does that cube relate to? Which one of these numbers? You know the answer, it's both of them. So let's deal with them one at a time. The cube of 1.8, it's 5.832, and that was pretty simple. And now that we've taken care of the units, why don't we take care of our 10 with the exponent? And it is 10 with an exponent of -4. 4 to the power of 3. what are we going to do? We're going to multiply the exponents. Remember that? When the exponent is not associated with a number or a variable, we are going to multiply the exponents. So 3 times -4 is -12. And so we have 5.832 times 10 to the -12, and that is our answer. And I know what you're thinking. You're thinking, hey, everything that we've multiplied out and everything we've divided out has come out to a perfect 1 units spot. What if we had 2 units spot, or what if it came out to 0.00 or something like that? How do we deal with that? I'm glad you asked me that question. Okay, well, let's handle this the way we have been handling it. Let's multiply the unit spot times the unit spot. There you go, and you can see our problem. We have 2 numbers to the left of the decimal place, and we can't have that, but we're going to live with that for right now. And let's just multiply our tens out. And so we're going to multiply that times 10, and we're going to add our exponents, -3 plus 9, which is 6. And you probably already guessed what we're going to do. We're going to move that decimal point over 1, and we make this number smaller. So we're going to make this number bigger. We're going to make this number smaller by 1 decimal place. We're going to make that bigger by 1 exponent. 6 plus 1 is 7, and I moved my decimal point over to where it should be. That is our answer. And let's try this similar problem like this with division. Okay, let's deal with our units first. And that's 0.53, and that's the same difficulty that we had in our last problem, but that's okay. Let's deal with our tens. And of course, with division, we're going to subtract our exponents, and we're going to be left with -3 minus 7 minus 7 is plus 7. -3 plus 7 is +4, 10 to the 4th. And we have 0.53, so we're going to move this decimal point to right there, right? And that will make it a bigger number, right? 0.53, and we're going to make it 5.3, so that's a bigger number. So what are we going to do here? We are going to make it a smaller number, and that is our answer, 5.3 times 10 to the 3rd. And I think if you do your homework and you play around with these numbers a little bit, you're going to find that after a while you will get used to it. So if you do your homework and you find that these numbers just aren't doing what they're supposed to be doing and you're getting the wrong answers, watch the video again. Nobody's stopping you from doing that. And oh yeah, one more thing. My friend would like to say goodbye to you. So say goodbye, Fluffy. Say goodbye. Okay.